I'll be sitting down if, is everybody okay with that? I don't like standing up. It's not a natural position for a software engineer. So I want to start with a question. I want to ask how many of people in this room have sent any. And now keep your hand up if you also send a self-test. Okay, that's kind of what I expect. All right. So the presentation is about everything network testing. We have done a lot of work over the last 6 months, I think, to improve the self-test infrastructure for networking, and hopefully it will grow. So I will cover both the motivation for it, where are we going with the infrastructure, what the gaps are, what the motivation is in terms of driver testing, and also basically how to write a test. So we have, we have 45 minutes, I think, so we should be good. So first, when you look at the Netdev infrastructure, you may see this word, NIPA. I wanted to clarify what it is and what it isn't, because it gets confusing to people sometimes. So there's a repo on our GitHub on the Linux Netdev, inside the Linux Netdev GitHub org, that basically contains all the scripts that run the test. So there's no test inside NIPA itself, just a bunch of Python and Bash scripts which can hook into GitHub, into Patchwork, pull out patches, build them, test them, and basically populate Patchwork again. So all the tests and all the libraries that we use for the tests are either in the kernel tree, or there are things like IPRO2, obviously, which lives outside, or Etho, which have their own Git repos. But inside NIPA, it's just a bunch of scripts and a bit of UI, or HTML, you know. So first of all, I want to give you a bit of background and motivation about why we do testing from perspective of the maintainer. And I think you may see me telling people on the list not to direct submitters towards the Patchwork test and the results. And hopefully this section of the presentation will explain why and what we actually use it for, because I think a lot of people are used to having test automation be more developer centric. And while this would be amazing if we had something where you can submit patches and they get tested and you get a response. With the limited maintainer time, we pretty much the Patchwork automation we have today is primarily focused on getting saving maintainers time rather than helping developers. So on this slide I put a example patch series, life cycle of a patch series. We start with version 1, then someone reviews it, then someone sends the version 2 to the mailing list, they get reviewed again, then version 3, everything looks good, but then the maintainer applies the patches, and it turns out that they don't build, or there's some warning, because we can only check that if we do testing manually once we apply, and then we reply again, and then there's a v4 which applies, and then some other bot, like kbuildbot, replies to us and says 3 days later that there's a bug in the series, and then we have to keep a spreadsheet that keeps track of all the bugs that are outstanding from all the contributors, and remember to ping them, because people don't remember to fix their stuff. And then those are basically the bots that would give us feedback. The buildbot was practically the motivation while we started doing the test automation, because buildbot is great, but it's fairly unreliable in terms of timing. You can get a buildbot report within 12 hours, or you can get a buildbot report 4 days later. And as maintainers, we don't know how long to wait, basically. So we need to get stuff build tested, because we don't know how long the buildbot queue is, how well they're actually basically keeping up with patches. There's self-tests. There are people at Linaro, I think, primarily, who run self-tests and report bugs to us. Those are nice, but it's really hard if it's not our environment to figure out whether the problem is basically something got broken or someone just didn't configure the environment correctly. And obviously developers usually test on their development machines, and they have everything installed, and they don't think about checking whether something is installed. So the tests don't fail usually in a nice, we forgot to install way. It's just somewhere down the 5,000 lines of code that says this doesn't work. I need to figure out why. So with the test infrastructure, we basically managed to cover these two, the ones that I didn't cross out. We can build all the patches and make sure that there's no warnings and like stupid basically things that the static checkers can check. We can also run self-tests. The sysbot is obviously very powerful and useful. Replicating sysbot and to run it basically on all the patches that get submitted before they get merged is a bit too much of a task for us now. So that's like a bit against the gap in terms of the things that already work, but they're not integrated with like pre-commit checks. So this is the timeline of how the testing infrastructure has developed. So back in 2020, we started doing the build testing. Took us until October 2020 for various life-related reasons to actually run it on every patch. But since then, we've been reporting the checks to patchwork and basically build testing every patch before we even look at it. And then last year, around October, I think because of accumulation of various factors, we started looking at running self-tests. I think, yes, one of the reasons was there was complaints during NetConf in 2023 that we merged patches and then people find out later that they basically broke their use cases. So there was an ask to basically do some testing before we commit, where we develop all this infrastructure, and unfortunately the people who are complaining don't actually started contributing tests yet. So I'm looking forward, you know who you are. Yes. So we started running basic tests in October. They were mostly KUnit tests. That stuff is really easy to integrate because you can just run a script and it gives you a JSON. So it's really trivial to integrate it as a pre-commit check. The self-tests are much less easy to run. And basically, I got the KUnit test to work within like a month or 2 weeks of work. And then I was procrastinating, and then I had to we were writing with other maintainers like a retrospective on 2023. And in that retrospective, I put a sentence that said, the huge achievement this year is that we run KUnit tests. It was so embarrassing that I actually, by the end of January, I had everything running to also run the K-self test and like basically all the tests that we had. Because the end it's 2024 and we still don't run all the tests we have. That's not great. So in January 2024, we started running all the tests, and since then, all the K-self tests, and since then a lot of people in the community have been basically helping to make them more stable, adding more tests. But I think the primary effort for the first few months was just to root out all the flakes. There's a lot of flaky tests, especially because we run them inside the virtual machines. The performance, anything that's performance related and timing related becomes quite unreliable. We have some workarounds workarounds for that I will talk about later. And for the curious, I think the cost of running the entire thing for us is about $2,000 a month, which is we're very thankful for Meta for sponsoring that. But it makes it slightly more problematic for us to like basically give the keys to the infrastructure to other people in the community. But that's something we need to address right now. It's all running basically on Meta's infrastructure. Okay, so with all the tests that we have, now the experience for the maintainer is much better. I got here the blue line as the build testing, the green right and as running K-self tests. So basically someone submits the test, then someone submits a patch, we get it build tested automatically, and we run all the self-tests on it, and we immediately can notice that either it breaks the build or there's some breakage in K-self test. And the V2 is basically hopefully code that is just for human review. V3, it gets merged, and there is no V4, and there is no follow-up. So a lot of maintainer time saved. Now this is where we want to go to. So the red stage is basically like distributed testing. Right now we run K-self tests, which are all on basically software tests for the networking stack itself. But a lot of the problems that we get with the increasingly hardware-related stuff are because something broke in a specific device driver. So we need to integrate another loop into this build cycle, into this testing cycle that will be testing devices. So I didn't mention this, but actually, I got next slide. I should. So these are the timelines for how long it takes to test the various things. The builds depend on how many patches we get an hour. Takes between 1 and 12 hours. If there's a huge patch series posted, that takes a long time. That kind of clogs up the pipeline. But yeah, usually it's around 3 hours. Then the self-tests run every 3 hours on everything that's in patchwork. But for hardware testing, we expect that the timeline will have to be longer. We want to keep it basically the loop, the entire loop from build to driver testing, stay under 24 hours, preferably. But yeah, we expect the driver testing would take longer. All right. Okay, so that's my last slide. Yes. So as I said at the beginning, this testing loop is kind of so far has been very maintainer centric to save us time and to save us the follow-up handling. The question is like, how do we make this more friendly for developers? And I would like to have a tiny discussion at this point to ask people whether they have any ideas or plans to contribute to the infrastructure that will basically be submit a patch and it runs the test and it tells the developers without actually posting on the list. Does anyone have any comments or thoughts on how we get there? Andrea.
Something you didn't mention is that it all runs inside a Docker. It is, in theory, possible for anybody to get this Docker image and run it themselves. Should we be advertising that much more? Should we be pushing back on people who don't do that?
Yeah,
Should we fix it as well?
The only one that fixes it. I think so.
Yeah, that thing is annoying. But
I was just saying, theoretically speaking, that's true, but practically, I think I'm the only one using it. So I've been sending patches to the Docker file to fix it up periodically, as much as I get around to rebasing our version of it. So, I mean, I'm all for more people picking that up, but be aware that it's not totally painless.
It does take quite a while, right? Like, because it builds almost config, like the warm-up time, depending on the machine, is going to be around an hour or two before it can actually start testing your patches.
You think about a typical driver development of being a year. What's 12 hours? Yeah.
It's already there on Nico? Yeah. There's a script that you can run basically. Then the test that we do for build testing, at least, you can run it locally and it downloads everything and runs the same. Like the output isn't really nice. I don't know what you do with the output. You have to like look around the output files to see if there's no failures, I think. But this is documented on the NEPA GitHub? I believe so, yeah.
I'm not sure I'd say documented in the sense that there's a actual file that describes like do this, but it's basically just like /run.sh with a couple of patches. /run.sh. Like there's a script that builds the Docker and runs the patches inside of it and everything. You don't have a lot of setup to get it running, but as Jacob said, it can take a couple hours to compile everything first, and then you do need Ccache and all that. So you might want to have a pretty strong machine to do it on.
Also, don't actually need to use the Docker. When I integrated the Rust stuff, I was just running Netdev.
Yeah, I mean, most of the NIPA techs are just bash scripts, which you can run direct. But they mess with your tree, so you have to be careful.
So I guess this gets a little into what I'm going to be talking about on Friday, but I found it can be difficult to get things up and running, and especially when you want to be focused, like when we're on FBNIC. I want to make sure I don't break FBNIC. If I'm using a stable kernel already, so I don't want to have to test all of the network stack. I want to be able to test FBNIC and the things that FBNIC might break. So I get quick feedback on my patch. That's kind of what I get into with the thing I'm working on, but just making it super, super easy to run. Because again, I don't want to just have me running it or you running it. I want it running every place, like in lab teams, in kernel teams, and manufacturing. These are people that don't fully understand networking or Linux in general. They just know to run a script. And so making it just brain dead simple to be able to run these tests and get quick, really readable feedback that are actionable is something that I think would benefit everyone.
I think that's one difference between it's for maintainers and it's for developers. They're different people and they have different expectations.
Yeah, and in theory, there's more of you, but I feel like I'm doing most of the work. So, all right, let's move on. Thanks. You can keep the mics, I guess. Actually, let me get one. I don't like holding this. Yeah. The question was whether the NIPA Docker file runs all the K-self tests too, which it doesn't. I mean, yeah. For K-self tests, you also need to do virtualization to virtualize the kernel that you built. That's doable. Yeah. The self-tests though, they really take, like, we have 4 VMs splitting the work and they take 3 hours. And there's multiple of 4 VMs. So, I mean, they will probably take 24 hours to run. Okay. Okay, so shifting gears, as I said in this slide, we would like to also run this test on the drivers and the hardware. So this next section will be about motivation, about why do we care about testing hardware. So the main motivation really is to bring the vendors and the users and the developers into one place, which should be the upstream community. You know, everybody can work on the same set of tests, have basically the development be more streamlined. The improvement of the code quality, I personally am not a huge believer in the test. You know, there can always be bugs that the tests haven't caught, but I think the test as a way of focusing the development and defining the features is much more useful. So I'll go into like another detour about how the Linux development works and why it's problematic without having upstream tests. So the basic idea of the Linux development is that we do frequent releases. We do basically a release every 2 months. And that gets the code into the user hands very quickly, and then we can basically quickly address any bugs that appear. And I mean, I don't know, most of you probably work for a commercial company. Doing releases every 2 months is like crazy in the commercial world. So yeah, we actually are delivering on that pretty well. And obviously there's a large, broad scale of use cases. So doing testing at the Linux level is probably unfeasible. So I think for the most of the kernel, this in theory works pretty well. But the picture isn't really complete because we do development, and then instead of the code going to the hands of the users, first it sits in the next tree for 2 months, then it sits in the RCs for 2 months, and then it sits and waits for a distro to update their kernel for some time. So the feedback loop for a user to complain basically when that something did not work as the user expected is very long. And this is an example for how it looks when you work at a hyperscaler. You also do development and net next into next tree. And then the features run in the production kernel, and then they get rolled out in some form. And then 12 months from the time you develop the feature, you get feedback from the people who you developed for that it might not be exactly what they wanted. And I can complicate this picture a little bit more because the people ask you for the feature, and then you have 6 months of doing something else, and then you do the development, and then you forgot basically what they said, and it gets longer and longer. So it's kind of looking something like this. You develop the stuff, get it into production for maybe 6 months, and then you iterate on the fixes. And something that I haven't mentioned is that that's all fine if you're doing this actually in-house. But for most of the features which require hardware support, you also have to feed a vendor into this. So you go from a kernel team inside the company to a vendor, back to the kernel team inside the company to the user, and then you find out a long time later that it's not actually what the user wanted. I don't know why this picture is here, but maybe some of you are familiar. So the goal of the testing, from my perspective, is to get rid of the iteration, right? Like we want to make sure that we can write the tests, agree on what the feature is supposed to be, prepare everything, maybe write a Netdev model for what the feature is supposed to look like. We can have those tests ready. When the vendor is ready, they can run the test on their side and upstream everything. Upstream can test that the feature works as expected, as documented. So basically goal one for doing driver testing is to improve our ability to deliver features to the users in a way that's much less frustrating. So yeah, the tests can come in much earlier in the development process, be consulted with the users, or even contributed by the users. We have done some things to try to like standardize things through standard bodies. Willem is over there. He spent a lot of time at OCP trying to get vendors to agree to basic features like how to do RSS. Turns out there isn't much uptake, but if you run a test for RSS, that's much easier. Okay, so the user participation part is basically that we can get the users to contribute to both to define the features and also to share the validation effort. So like if you have a use case and you care about some particular way in that you get you get an RSS context you configure in a way, you do the 0 copy, you should be able to send that as like a basic test upstream, and we will run it and validate that the vendors don't regress your use case. I think that should be something that we are open to. Basically catch any regressions in the entire stack, including the drivers and the hardware, before they get into a release, so that you give users more confidence when they upgrade to a newer version, and hopefully that improves the release cycle, like velocity. Okay, I didn't know where to put this, but there's also a question of right now. I think Jamal likes to say that the work that he's doing is how well inside the TC model, and I think that's to some extent true. I think most people don't understand what the software model is and where it came from. So when we implement offload features in Linux, there's an expectation that there will be a software version of it. I'm not entirely sure where that came from because I wasn't around, I don't think. But I think it came during SRV days. Maybe Alex knows better than me. When everybody was trying to do their own thing, and every vendor has their own like limited implementation that was completely divergent, and we wanted to standardize on like standard building blocks like bridging and routing, and instead of reinventing custom vendor things. Then there are some benefits obviously for this model. One clear benefit is that you can validate that the hardware does what you expect because you have a software model and you can compare them. There are some downsides, and I think why the slide is here in this presentation is because I think this model of like providing software implementation is showing its limits in certain aspects. And if we have features which only make sense in hardware, like RSS, writing a software model for RSS makes no sense. Writing a test for RSS makes much more sense. So I think using testing as the model, or at least as the validation, is in certain cases more like beneficial.
I feel if a response is going to be a digression, maybe I could talk at the end.
Sorry?
I feel if I say something about this, it's going to be a digression. Why we have a software data model as well.
Okay, go ahead.
It's mostly for exception paths. Of course, testing. I want to test what I think the hardware should do, the input into a software data path should have an output that's the same as if you input X into the software data path, you get an output Y. If you input X into the hardware, you get an output Y. The implementation doesn't have to be the same, but the black box has to have the same input, producing the same output. And it's useful for testing, but more importantly for things like to see exception paths and extending things that the hardware can do. So they work together.
Yeah, I think they work together, and in many cases that do make sense, but there are cases where they don't necessarily make sense, and then we are left by basically with this model does not allow for basically hardware only feature very well. So I think that's a gap that testing would
Fair enough.
as well. I think I'll cover this. So basically quicker iteration and less time wasted, and increased user participation. And the benefits to developers is, I don't know how other developers feel, but when I was working at a vendor, I felt like upstream testing is quite hard because there was lack of support. Basically, the self-test, some people made them work basically by their own effort, but there wasn't any like existing thing that I could just plug in my device into and write tests that would cover my work. So what ended up happening is I would write the test for like the internal testing frameworks, and then everybody has their internal testing framework, and then you might change a job, and then you leave all your tests behind. I mean, I think we should basically fill that gap as an open source community. So hopefully that's convincing to the developers. Okay. So now I will switch gears and talk about the infrastructure that we have. I already covered what's inside the repo. What we do is to run the self-test, basically both the self-tests and what will happen for the hardware testing is we get all the patches from Patchwork, we put them in a branch, and we test them all together. The failures are sufficiently infrequent for that to not be a problem. That the fact that we have multiple patches basically in a single branch that we test together, it hasn't become a problem yet. And the amount of resources we would need to test all the patches is prohibitive, basically. So this is the flow of the entire system. I know it's probably unreadable, but there's a patchwork on the left. Oh, you can't see my pointer. Okay, there's patchwork on the left. We ingest the patches. Then we create basically a JSON file with the branch descriptions. And then there can be a remote site. For instance, Jamal runs the TC test as a completely independent test executor, which basically the remote executors just watch the JSON file for new branches to appear, run the test, and pop out another JSON file, which we then take back into our system, collect the test, and for some intermediate boxes, repopulate the results back into Patchwork. So I think the main takeaway from this system is that we have this central infrastructure, but to add your own runners as a vendor or as a system maintainer, it's relatively simple. You just need to watch a JSON file and then output another JSON file, and it will all appear into our infrastructure. Okay. I think I was planning to show maybe. I go to the URL. All right, so this is the main UI of the system. There's a bunch of services on the left that basically shows the status. On the top left is the queue for patches that need to be built. If there's a lag, basically we get too many patches in an hour, there's going to be a patches showing up here and the queue length is going to increase. And then the K self-test results are on the right. Most of the failures are actually flakes at this stage because we closed NetNext. So anything that shows up here is a flake. Below here, we have like a tiny cheat sheet. Whenever test fails, we retry it. so we can basically judge whether it's likely to be a flake or not. The PMTU test is also a flake, but it runs for too long, so we don't have time to retry it in the 3-hour cycle. There's a list here of the crashes that we noticed. The TC, which one is the PMTU? Yeah, the PMTU, I think, leaks test, so it's a known problem that we need to figure out. Yes, and there's some graphs, how much time everything takes, and basically the resource utilization of the system. And then the rightmost graph, I think, is most useful. If the system starts, basically, this is how many hours the patches have to wait to be tested. So if your patches don't get tested, this is what you can look at and figure out whether that's kind of expected because the system is just overloaded. Further down, we have a list of tests that we ignore, are too flaky or known to be broken. I think all the known to be broken tests are now fixed, so these are just flakes. And there we can also ignore crashes. And then these are the results for the tests that we currently ignore. Like, as you can see, some of them pass, but yeah, they're too flaky. So from this, you can get to, let me click on that. This is another part of the UI that you can get to if you click in patchwork. At least all the tests for a given runner. In this case, at the top, you can basically do some filtering, not too complicated. The nice feature that we have, when we find the one that failed, the nice feature that we have is on the right, you can click on the matrix. This matrix, I'm too blind. Can you tell me? Can someone see if this is? All right. So this shows basically all the runs in like a tabular form. So you can, let's remove the name of the test. So you can see whether the test is basically filing a lot or not. Yeah. But all the tests are here and all the failures are here. You can figure it out. Anyway, okay. And then the last thing I want to show here, I think, is this is a placeholder. Once we get to October, when the driver test will become mandatory to get the supported status in the maintainers file, this is where the driver test will appear. For now, we don't have it. All right. So a few words about the executor of the gap. That's the one thing that the NIPA script that was talked about when Docker doesn't run basic self-test. I think this might be useful for people who want to develop the runners for their drivers to run basically on their own premises. But it's not currently well suited for running hardware stuff because it uses virtualization. But you can at least see how all the JSON operations work, and there's like some Python classes factored out there that should be reusable. I mean, obviously the NIPA repo is open for contributions, so if someone develops like a script or whatever that runs their hardware test, it's more than welcome to submit it. We try to reuse as much stuff as possible, to not invent our own things. Obviously, I mean, we invent the entire UI and everything, so we're not that good at it. But we run the virtme-ng, which is, I think, Andrea, his name is, from Canonical developed. It's a wrapper around QEMU in Python, and it can build the kernel for you and execute, basically run the VM and mount your local file system inside the VM. So you can basically run everything that you see on your normal development environment will be visible in the VM. You don't have to like copy the test or anything. You just build a VM and run the script as if you get a bash basically inside the VM, and you can run the scripts on your newly built kernel. Okay. Are there any questions before I go into how to write a test? Honestly.
I was wondering what you envision in terms of sort of a security model when someone's running tests on premises on their hardware that basically consumes arbitrary patches from the list that might, whatever, change the build system to call out to some download or whatever and start mining Bitcoin. Who knows what?
Yeah, there's no guarantees that the things will be secure. So you have to put it in a DMZ or some secure location. I think for hardware testing, some people at NVIDIA were talking about basically forwarding the PCA device into a VM. And then the only thing that can get compromised is basically the device itself. So you can you have to deal with that part. But I think it should be doable, hopefully. Unfortunately, if we review the stuff for safety before we put it in the testing branch, it kind of removes the gain of not having to look at broken patches. So it's a trade-off.
Yeah, that's fair. I mean, I do think it's doable. Just think that people should be aware of it. Like, no,
Yeah.
at least as far as I understand, there's no gate here, nothing, or whatever gets submitted to end up in your CI system.
That's a good point.
So
So
kind of
if we
tying in
have
the
a
last.
JSON file with results, how do we get it picked up? If we have a JSON file with results, how do we get it picked up? Do we email you?
Yeah, just email me and I need to add basically to the database the URLs from which we fetch, and that's it.
Okay.
Going back to the last talk a little bit, if I'm writing a driver test that requires a proprietary tool to turn some firmware knobs, is that allowed? Or do you have to only use open source tools during testing?
What do you need to transfer? I mean, the test needs to be applicable to more vendors. If you're a vendor, we will not take like tests which are not applicable to more than just you, right?
Well, I mean, like if it's a driver test, right? Those tests are for driver and for the hardware.
Yeah.
And so like even with FBNIC, we have tools that are testing with GMRT that we're not open sourcing that I already have running today.
Okay. I think, yeah, if you have testing some internal stuff, I don't think that's a good fit for upstream test. I mean, you can use the infrastructure. The Python libraries are all like isolated out.
Sort of adding on to that question though. So are you expecting for the driver test that you mentioned that vendors would run, are you expecting those to be running the self-tests that are upstream, or are you expecting those to be something that, the vendor might have their own test suite or whatever that just runs on top of that? Because those are two different things in a way, right? Because there's some requirements for the self-test that, like you just discussed, and then there's some requirements that the vendor might want to test things a different way. So I don't know if you want to tie those together in any way.
I think we can accept both, but the understanding for the self-tests that are upstream is that we'll have to figure out basically what's failing because of incompatibility, and for the vendor tests, we would expect it to be all green. That's the only requirement, right? You have your own CI and we want to plug it in and let us know when we break stuff before it gets committed. That's more than welcome. But then it has to all pass because we don't know what the tests are doing.
So along those lines on the vendor test, so the idea is each vendor would run their own test string and somehow we would submit tests to it.
So the tests are already upstream. We have, I think, a couple, I don't know how many. We have a test for RSS, for checksumming, for flow filters. We have a few tests already upstream, and hopefully that list will grow. They all depend purely on upstream APIs. The standard APIs we have for statistics to check whether packets landed in the right place. Some, IF packet to do the checksumming. So those can be vendor independent.
Well, let me give an example. Suppose we wanted to that would affect many drivers, kind of a fundamental change, which one of the things we're intending to do is fix some checksum offset. So we affect all of the drivers, or a high number of them. So will we get sufficient coverage from this plan, and I guess in time as vendors add actual device support?
For the vendors who add themselves to the group, I don't know how many vendors will, right? We have like 200 drivers. And I expect there might be single digits. But if we get the most popular vendors, at least we get more confidence, right?
Well, the one question I would have is in terms of the NICs, they're like massively firmware configurable. are we going to have any steps to actually try to record what the configuration is before running the test? Because, yeah, the one concern I would have there is, yeah, one device can end up looking like probably hundreds, depending on the number of tunable knobs they have and how they'll behave in the test.
Yeah, I think was thinking so far that we definitely need to do like a devlink info snapshot that will give us at least the versions of the firmware components and the version of the hardware, but we'll probably need more information. We'll figure that out as we go, I think. I expect that for every vendor, we will need multiple devices, right? And multiple firmware versions possibly too. All right, no more questions? Test. So in terms of how to write a test, and how the entire infrastructure in goes up. So the driver tests I was talking about that are upstream are all integrated inside the K self-test infrastructure. You can type make K self-test run test, and they will run. The only tricky part that exists is that you have to export basically a couple of environment variables to point them at the right interface. And if the test need to send traffic, you have to point it at the remote machine. And they either, if it's a remote machine, they can SSH into it to execute whatever command. And if you have multiple interfaces on the same machine, the tests can use net namespaces to basically execute themselves in the right net namespace. We have tests in Bash, C, and Python. I think a lot of tests so far have been in Bash. The Python is a more recent development. For the C code, we have a K-self-test harness, which is useful to basically give a unit test structure to the test. But C code is generally for local testing. The only thing I want to call out, most of the tests we have today don't use the KTAB. I don't have an example. KTAB is like a format for the output so that we can parse out subcases and like track subcases, as well as the entire result for the test. Most of the tests don't support the KTAB format for the output. It would be very useful if the new test did, because we can track things at a much better granularity if we can track subcases. So in terms of what you have to comply with to add your test to the infrastructure, the requirements are really not like onerous. The main thing is return code for the program. You return 0 if the test completed successfully, and 1 if it failed, and that's pretty much it. There's some extra, more advanced return codes, but yeah, not too many of them, and they should be pretty obvious. I mean, I guess the xfail and the xpass, those are interesting return codes. We are currently for the software test using them to indicate the test, which we know should, like, basically, if something skips in software, we consider that to be a limitation of the execution environment that someone should go and fix, basically install some CLI or whatever. And if you know that you can't run the test because it only runs on ARM and you're on x86, then you can use xpass or xfail because you expected a fail, kind of the delineation we came up with. And then you write your test, make sure that it exits with the right exit code, and then you just in the make file, you assign it to the right variable, and that's it. The test will run as part of K-self-test. There's a slight differentiation there between the make targets. For scripts, you put it in one, and for things that need to be built, you put it in the other. It's very straightforward. It's not hard to add a new self-test. So I have more details on the C one. The C test harness gives you a couple of useful like unit test functionality. You can define your tests as inside the test macro, and then all the tests are like automatically executed. You don't have to add them to any list; they get auto-added. And then you can also the self-test harness provides filtering, so you can run a single test case. There is some support for fixtures, so basically you can define the inputs and then have the same test body, and the K-self-test infrastructure will execute the same tests with multiple declarative inputs. And that gives you the basics like expect and assert. One of the more recent developments, I think you can use the in-kernel libraries in your tests too. So if you want to use Netlink, you can use YNL, or you can use libBPF stuff. All those libraries are like supported in the K-self-test, so you just add them. I think you just need to add your like program to the things that depend on the given library, and it will all get built and linked. Python scripts. There are some libraries for the Python scripts I'm less familiar with, but the general as I said, the requirements fairly minimal. You can look at the list. I'm not gonna go through all these. Python's tests are more recent. We have a basic infrastructure. Maybe let me jump to the example. So this is how our actually real tests for, I think, for XDP features looks like. For anyone who knows Python, hopefully this is very straightforward. We added a couple of macros added a couple of functions to do asserts, and then there's this ksft run function that executes the test in the list, and again there's support for netlink. You can use netlink, like raw netlink, using the YNL infrastructure. This is the layout of the directories for reference. Most of the networking tests just live under net. There's quite a few tests under forwarding. In general, there's some people who add so if the driver tests are under driver's net, I guess that's the most important part. Driver tests are under driver's net. And the tests under driver's net run both on Netdev sim and on real hardware. You have a test which runs only on real hardware because Netdev sim doesn't have the features. You can put them in driver's net hardware. The difference is that we actually execute the driver's net already today in the virtme environment. The hardware ones are currently like up to contributors to run because we don't have the driver integration yet. And these are the environment variables that I mentioned earlier. So if you want to find the test as a real device, you set the native environment variable, and then there's some more environment variables for communicating with a remote machine. That's not complicated. And the last one is we run the test both on a production, like full performance kernel build, and we run it with KSAN and the KMEM leak and all the debugging stuff enabled. And obviously that throws off all the timing. So at least in the Netdev infrastructure, if the machine is like with a lot of debug enabled, we export this special magic variable, machine is slow. And then some of the tests which depend on timing can automatically like lower their expectations and prevent basically failures. Because slow is slow. Yeah, so this is all my slides, I think. I have obviously there's a lot of opens for the hardware testing. We will learn as we go, as we always do. I think for one of the first one is like how often do we do the testing? I don't know how much hardware people can put in, and basically whether we can do it on 12-hour cycles or we can do it shorter. The shorter the cycle, basically the easier it is to look through the patches and figure out which broke what. But I don't think 12 hours would be too bad. The second point is what Alex basically asked about, is tracking the flavors of the hardware on which the test runs, because just saying that it runs on, I don't want to pick any vendor driver right now because someone will be upset at me, but there's a lot of drivers which basically support 10 generations of the hardware. So just saying that it runs on driver X doesn't actually tell us much, so we need to actually know that it's running on to have more confidence. And there's a couple more things, but we'll figure it out. Hopefully people will contribute. That's it. Any questions, comments?
So the cell tests seem kind of almost like an all or nothing approach where you either run all tests or you're not running them. And so when you're working on specific parts of the kernel, especially a driver, is there any idea of saying, you know what, I only want to run a subset of these tests that I know that my driver could affect? But like, just random example, I'm working in FBNIC. I know I'm not going to break bonds or something like that. That's a totally different driver. Like, can I run stuff that I know only my code can affect, so I'm not touching anywhere else in the kernel?
I think there's some work being done inside like the self-test subsystem that is supposed to provide some basic form of matching that, you can tag the self-test with what it's testing, and somehow if you don't touch the files which the test is supposed to affect, then it can get filtered out. We don't have any of that integration. I think it's a hard problem, right? I mean, you need to throw some AI at it or whatever.
Yeah, I mean, I'm just thinking that like we want these, like you were saying, run for 12 hours. But if I can get really quick feedback by running a subset of the test, and then maybe nightly or something like that, there's a longer running test of these patches, I can get much quicker feedback, so I don't have to wait until 12 hours with a full workday. I'm not going to look at it until tomorrow, right? And so if I get this quick feedback, I can make iterations much quicker, and then obviously make the whole process faster.
Yes. I think if you are a developer with some experience, you with all of those tests, you can just run them as scripts. You don't have to run them in an infrastructure. They just work. So if you know what to test, you can test it in a more direct way. If you are just submitting tests for some auto tester, then yeah, it's a more complicated problem. I would like to see some solutions as well.
Okay. And then another question I had is, are these tests looking at like F-tool errors or anything like that? Because that's one thing that I've been actually doing with our internal test suite at Meta is every test I run, I look at F-tool errors. I look at the log. I see if the test produced an error that's unexpected, because I've found in tests where all the tests pass produces like errors in D message and things like that, but just weren't caught unless I had a explicit check for that.
So we check for known stack traces, like we will check for known messages and stack traces to catch like basically warnings, case on warnings, stuff like that. We don't check for driver specific messages. I think that might be slightly hard. I mean, the expectation is if something fails, you should know it from the like second order effect, right? You're directing traffic, the traffic didn't get directed. Whether it's code an error in the logs, I don't know. Does it matter?
Well, it's more like if you run a test and it causes a lot of high amount of packet loss, but high enough that it's visible, but it still doesn't cause the test to fail, that's just going to get ignored.
Yeah, I think well, as we go along, we'll learn those things and hopefully augment the infrastructure. There's like places where you can add checks to validate that the environment is still sane after the test. So you could basically add whatever checks we need in there.
I think on one of the slides you had the remote IP addresses. So it looks like the driver tests have support for like two node tests, where one is the receiver and one is the sender. Is that correct?
Yes.
Does the non-driver test also have the same support or no?
So yes, I believe so. And I think the Switch folks, like the NVIDIA folks and the David Akern, may have more information on that, because that's already supported for switches, for instance. It's like case by case. So even for driver tests, there are some which don't require a remote, and then you don't have to export that variable. But there's also like software for software tests, we generally do something where we like just add a V pair, right? Yeah. So drivers is where you actually start to care. I mean, for other use cases, but there are some in the forwarding directory specifically. There are tests which can already also run on hardware, and you specify multiple interfaces. And yeah, but for switching, it's easier for them because they have multiple ports. So they just expect that the ports are looped, right, Andrew? Yeah. So yeah, it's kind of complicated.
I see.
All right. I think that's it. Thank you.